today's video is on integration using residues. In today's video, we are going to determine the poles of the function f of z is equal to z square by z minus 1 square into z plus 2. And second question here is f of z is equal to z square by z plus 1 square into z plus 2. See here, so what is the function given? So the function given is f of z is equal to, this is z square by z minus 1 square into z plus 2. And in order to find the poles, we have to equate the denominator to 0. That is z minus 1 square into z plus 2 is equal to 0. So if I equate this minus 1 square to 0, so here we got z is equal to 1. So this is a pole. So this is a pole of order 2. So here it is a pole of order 2. A pole of order 2. So here we got the pole z is equal to 1. A pole z is equal to 1 of order 2. And here, and again if you equate z plus 2 to 0, here z is equal to minus 2. So which is a simple pole. So this is a simple pole. So after equating the denominator to 0, so we got two values. Z is equal to 1 is of order 2. It is a pole of order 2 and this is a simple pole. Now we have to find the residues of this. So first of all, for simple pole, the residue here, the residue of f of z at z is equal to minus 2 is nothing but limit z tends to minus 2. This is z plus 2 into f of z. So we have to eliminate that z plus 2 from the function and again we have to substitute the limit. That is limit z tends to minus 2. This is z plus 2 into f of z. So what is f of z here? The first function here is z square. See here, this will be z square by this is z minus 1 square into this is z plus 2. Z plus 2. Now we have to eliminate this z plus 2 and again we have to substitute minus 2 in place of z square. That is minus 2 minus 1 square. So minus 2 square is nothing but 4. This is minus 3 square is nothing but 9. 3 square is nothing but 9. So this is our residue value at point z is equal to minus 2. And next one we have to find out the residue of f of z at pole z is equal to 1 of order 2. So here we have to find out residue of f of z at z is equal to 1. So this is the pole of order 2. Now I am going to use the formulae, that is residue. See here, this is residue of f of z. See here at point z is equal to 1. Here will be limit z tends to z naught. See here 1 by m minus 1 factorial. This is d by dz power. This is m minus 1 into this value is z minus z naught power m into f of z. This is f of z. Now here, if you kindly observe this one, here the pole value here is 1. Here order. So order m value is equal to 2. So pole z is equal to 1 of order 2. And now if I substitute here, this will be residue of f of z at point z is equal to 1 will be limit z is equal to, here our pole point is 1, m value is equal to 2. The order value here is 1. This is d by dz value. M is equal to 2. So this is 2 minus 1. This is pole value is 1 square into this value is f of z. Clear? And now here this value is equal to limit z tends to 1. This is again 2 minus 1 is 1 factorial. This is d by dz times of this is z minus 1 square into what is our f of z value? Z square by, see here, this is z square by z minus 1 square into z plus 2. See here, the value here is z square by z minus 1 square into z plus 2. Z plus 2. Now if I cancel this z minus 1 square on both sides, this will be limit z tends to 1 d by dz of this value is z square by the value here is z plus 2. The value here is z plus 2. Now we have to make a derivative for this. So that is limit z tends to 1. So here this is limit z tends to 1. D by dz of derivative of z square by this is z plus 2. Z plus 2. So now we have to use UV rule. So UV rule is nothing but, so the derivative of u by v is nothing but this is v square v u dash minus u v dash. Clear? So this is u and this is v, and therefore if I make a derivative, this will be z tends to 1. So this is z square. So z plus 2 square into, again we have to write v for one time, z plus 2, and we have to make u a derivative, that is 2z, and again we have to leave u and make derivative for v, and again we have to substitute z is equal to 1. So here, so this will be 2z square plus 4z minus z square by z plus 2 whole square. So if I keep z is equal to 1 here, this will be 2 plus 4 minus 1 by 1 plus 2 square. So if you see here, this will be 6 minus 1. The value here is 5 by, and this value is 3 square, the value here is 9. So if you observe the value here, the residue value for z is equal to 1. So this is residue of f of z at point at the pole z is equal to 1 of order 2. Order 2 value is 5 by 9. And here for the simple pole here for z is equal to minus 2, this is 4 by 9. See here, first of all, the function is f of z is equal to z square by z minus 1 square into z plus 2. We have to equate the denominator to 0. So we got z is equal to 1. Z is equal to 1 is a pole of order 2, and z is equal to minus 2 is a simple pole, and the residue value for z is equal to minus 2 is nothing but limit z tends to 2, z plus 2 into f of z. After cancelling z plus 2 and substituting z is equal to minus 2, so 4 by 9 is the value. And again we have to find out the residue of f of z at z is equal to 1. So here is the formula. So in this formula we have to keep pole value as 1 and m value as 2. If I keep z is equal to 1 and m value as 2 here, so here, and after cancellation and after making the derivative for one time and substituting z is equal to 1, so 5 by 9 is the value. See, please, if you go through this video for one more time, you will be understanding. So if you really like, please practice and pass it on to your friends.